So I'm Michelle. I'm really excited to be here. In preparation for this talk and coming to Australia for the first time, I listened to Australia's Top 100. And in honor of AC/DC being an Australian band, this talk is called Highway to Helm. There are also several other tragic musical references in this presentation as a result of listening to the Top 100. So that's a thing. So Helm is a project that I work on. And today I'm going to talk to you a little bit about how you can use Helm to install and manage applications in Kubernetes, and how you can do that yourself or with your team. And if you're not even ready for all of that, so a lot of you did raise your hands and say, you have used Kubernetes, but if you haven't used Kubernetes, that's okay. Helm can also give you the ability to check out what Kubernetes can actually do without having to learn everything from the bottom up. So there's a lot here to learn, I think. So by a show of hands, who in here has heard of Helm? Oh, well, that's a lot of you. OK, who in here has used Helm? OK, great, perfect. So just wanted to get a lay of the land. But before we go into that, I'm going to tell you a little bit about myself. So I'm a developer. My background is mainly in Ruby and Go. And I used to work at a company called EngineYard, which is a Ruby platform as a service product / service. So basically, we helped folks at EngineYard manage and deploy their apps on AWS without having to figure out the behemoth that is AWS. And we'd also help with things like database backups and migrations, fixing any vulnerabilities in your stack, disaster recovery, and those kinds of things. A few years back, though, we got really excited about this whole container thing. So Docker was becoming more and more popular, and Kubernetes was very young but looking very promising. So we actually knew that the PaaS game was about to completely change. And this is something that Brendan alluded to a little while ago. So we bought, or EngineYard bought, a little company commonly referred to as Deis, which was very into this container PaaS space. And this little acquisition changed my whole world. I went from developing mostly in Ruby to doing mainly Go and open source, and containers and Kubernetes became something that we at the company all lived and breathed every day. So we started with building a Kubernetes native PaaS called Deis, and we just continued building open source tools that basically helped people and organizations get on Kubernetes quickly. And it turns out that Microsoft also had similar goals, so we got acquired by them last month, and we continue to build tools that make container technology easier to use. But now, what's really cool is that I get to sign my emails as Michelle from Microsoft, which I think is really catchy, but nobody has noticed, and I've done this a lot of times, so whatever, I just wanted to kind of share it because I get a kick out of it still. This is a real story, by the way. So anyway, at Deis, we were working on this Kubernetes stuff, and we were really into Kubernetes. It provided this great abstraction layer, so we didn't have to worry about the underlying machines, and we could deploy our applications and not really worry about that. But we needed a way to install lots of different Kubernetes resource types into the cluster. And after that, we needed a way to kind of upgrade and roll back and manage that same group of related Kubernetes resources. And so this is kind of a common problem, because if you've worked with Kubernetes and you've deployed something on Kubernetes, chances are you're probably defining more than one Kubernetes resource. So this is a common problem that not just we were having, but other people were having as well. And so we're also having another challenge. So we'd build these Kubernetes resources or resource definitions, and we get them all working. But we wanted a way to package that up and version it so that we could reliably redeploy that group of things into different environments with confidence that we would get the same thing every single time. And basically, what we wanted was a homebrew or apt or yum experience for Kubernetes. And so we built Helm, which is a package manager for Kubernetes. But Actually, it's kind of like package management plus plus because we also do lifecycle management for your application. So you can do things like upgrade your application, roll it back, test it, which is a new feature, and delete your application as well. So a package in Helm world is called a chart. And charts consist of a few main things. So the first thing is metadata. This is just things like what's the name of your chart, description, what are the email addresses of the maintainers so you know who to complain to if you have issues, and semantic versioning and just things like that. So the second big piece is the Kubernetes resource definitions. And this is like the big main chunk of the actual chart. And these can be templated. So we support Go templating. And so if you're templating them, your configuration lives in a file we call values.yaml. And then the last piece is documentation. And charts live in chart repositories. And we'll talk about all of this one more time at the end. So charts are one of the three big components of Helm. So the chart is the expert-built recipe for installing an application. The idea here is if one person figured out how to put something like, install something like Prometheus or WordPress or MySQL or Postgres into Kubernetes, then you don't have to like start from scratch and like write all those manifest files from scratch. You can just use what they've done and build on that and configure it for your needs. The second piece of Helm is the values. So this is the user-supplied configuration, which can live in the chart, and usually there is default configuration in the chart, but it doesn't have to live in the chart. So you can have values that live outside of the chart, but in the end, when you install a chart and values into your cluster using Helm, you get something like the instance of that installation is called a release. And that's the thing that we manage. So given that you've already downloaded Helm and put it in your path, and you've got a running Kubernetes cluster, the first command, that you would run is helm init. That does two things for you. One, it configures your local environment to work with Helm, and the second thing it does is it creates a pod called Tiller in your cluster. Tiller is Helm's server-side component. It lives its humble life inside of Kubernetes as a pod, and its main job is to create and manage releases in your cluster. So Helm is the client, Tiller is the server, Kubernetes is the target platform that we're installing on, and it also stores the data for each release, or that's where we store the data for each release. And an instance of an installation of a chart and its values is called a release. So I'm going to do some demos. Or not. Oh, cool. Just can't click, y'all.
Okay.
Thank you. Okay, so this is the Helm init command in action. And basically it gives you that output, and we'll use kubectl to ensure that that actual Tiller pod is running in the cluster. And here that we see that it does exist. And kubectl, for those who are not familiar with Kubernetes, is the command line tool to interface with your cluster. Helm install is the next thing that you'll do. But before that, you want to kind of search for a chart to install. So here we're going to search for a WordPress chart. And there may be multiple, but we've gotten back one result here. And you'll see it's stable/WordPress. So every chart is namespaced by the repository it lives in. And we can see here that the WordPress chart is housed in the stable chart repository. And if we want to see other repositories that exist, or other charts that exist in the repository, you can just pass in the repository name to the Helm search command. But let's go ahead and install our WordPress chart. Here we got like a bunch of things back, so let's kind of dissect that. So the first thing to pay attention to is the name. Every time you do an installation with Helm, you get a randomly generated release name. Ours is Wobbling Mule. I have learned lots of new vocabulary words because of these randomly generated release names, so I highly recommend this. But if you want to specify a release name, you can do that with a flag on the command line. There's also some metadata associated with your release. And underneath that, there's a resources section. So the resources are everything that was defined in the chart that got installed into your cluster and its status. So that's all displayed there. And at the very bottom, you see a notes section. So this is some post-installation steps or a quick start guide. This is just whatever the chart author wanted to tell you about what to do after you install the actual chart. So let's grab the IP that the WordPress that we installed is running at. Oh, and you can see those credentials too that we can use for our blog. So here we can see that we have a WordPress blog, and we'll just try to log in here and make sure that our credentials work. Cool, so we have running WordPress, which if you're just running one little thing of WordPress, like don't use Kubernetes because it's like a waste, but just for example. So you can do other things with Helm as well. So this is the output of a Helm get command. Helm get manifests will grab the manifests that were installed when a release was created into the cluster. So say I am kind of a workaholic. So say I'm a workaholic and someone on my team, we'll call her Amy. Amy installed something into the cluster, and I'm in Hawaii on vacation, but I really got to see exactly what manifest she installed into the cluster. So I'll just run Helm get manifests and pass in the release name, and I'll get exactly what was installed back, just to make sure. So you can also do things like check the status. And the status is exactly what we got after we ran the install command. So you'll see those notes files, you'll see the notes that was given, and then you'll also see the updated status of all the resources associated with your release. So say you have a WordPress site, and you have some, okay, so I apologize for this demo because my accounts weren't working yesterday, so I had to fall back on a recorded demo from KubeCon. But we're just using this as an example to put some data into your blog. So here we have like a post. And we'll check out the version that we're running at of WordPress, and we see it's 4.5.3, and the latest version is 4.6.1. So we know that we should probably upgrade to the latest, because why not? Nothing bad will happen. And here we'll just grab the release name, and we'll upgrade Crazy Joey to the latest version of stable WordPress. And so you get that same output again. Let's see what's going on under the hood, though, using kubectl. So here we're recreating the WordPress pod. So this has a new image. So we're going to create a new pod. We'll watch those pods. OK, it's running. Cool, sounds good. We're waiting for it to be ready. It's ready. Cool, sounds good. And if we just refresh, we'll see that we're on the latest version. And if we go to the main page, then we'll see our post is still there and everything's intact. OK, so another thing you can do is delete everything associated with your release. So this is a release called Garish Ant. And if you, I don't know what garish means, so this is what I'm talking about, y'all. So Garish Ant has some resources associated with it. So we're going to use kubectl to kind of like check what's going on under the hood and verify everything is happening correctly. So we have some resources, and we're going to use helm delete to delete our release, which should delete all of our related resources. And so we'll use kubectl again to make sure that actually happened. Who pronounces kubectl kubectl? Yeah, me too, but when I'm doing presentations, I try not to, because it makes me giggle. So anyway, so here we can see that our Garish Ant should be in this list, and it is. All right, so if you're wondering where you can grab Helm, you can grab Helm using Homebrew or GitHub, the GitHub releases the releases section of our GitHub repo. And so let's go back, let's step back a little bit, and we've seen Helm, we had the basic idea of what a chart is, and so let's go back and revisit charts a little bit. So say you're ready to create your first chart. We'll help you do that with the Helm create command. If you pass a name, then we'll scaffold a basic chart directory structure that'll help you get started. And that directory structure of the chart looks a lot like this. So let's dissect that a little bit. So the first place that you're going to focus on is the templates directory. This is the place where all your resource definitions go, templated or non-templated. So that means if you have Kubernetes manifest today, you can just run a Helm create, dump your Kubernetes manifest in there, and you have a chart that's ready to be packaged and installed. If you configure your templates, then the values are going to go in the configuration is going to go in the values.yaml file, like we see here. And some tips for this is some best practices have kind of like arisen in the last several months. So generally, we're seeing that people use lowercase letters for their keys in their values file. They generally make the image configurable because that's the thing that you're going to update when you update your app. So it's just easy to have a knob there to twist. And generally, we're seeing lots of comments to make sure that people who are using your chart understand what's going on right off the bat and don't have to go digging too much. So you don't actually have to use the values file for configuration. You don't have to edit it manually just to edit configuration. You can use the set flag on the install command. And here we're seeing that we can modify the port using the set flag. It's nested under service, so we'll just do service.port equals 8080. You can also pass in a new values file altogether with the -f flag. So you might want to do this if you're installing in different environments. Like you might have a values file for your QA environment, your test environment, and your production environment. And so as you package up your chart, you may find that you need a dependency or two. So for example, that WordPress chart that we installed has a dependency on MariaDB. So there's two ways to define dependencies. One is the charts directory. The charts directory lets you vendor in charts as subcharts, and so that's one way to do it. An alternate way is to define the dependency in the requirements.yaml file to manage pulling in dependencies from hosted repositories. Documentation is very important as well. So the README is the first thing that people will see when they're using your chart. This just basically describes what the chart is, any prerequisites, maybe what version of Kubernetes it's compatible with. That's something you can define the metadata as well. You can detail out default configuration options and explain how to install and upgrade if there's anything magical that happens there. The notes.txt file is actually the notes section that got printed out in the status command and in the install command output. So that can be templated, which is really nice, so you can provide working commands to the user. And it's a great place for explaining post-install instructions, any quick start notifications as well. And popular charts tend to have very detailed and good notes.txt files is what we're finding. Metadata is probably the simplest part, actually, of this whole thing. It's just a YAML file with name, colon, whatever the name of the chart is, and a version and description and sources. We support semantic versioning for the charts. That's not necessarily going to be the same version as the app that's actually being packaged, and you can use that field to describe any breaking changes in the chart. And the last thing I'll say about the chart.yaml file, I think is something that people miss, is you should, if you're building a chart, define keywords, because then we use those keywords for like the Helm search feature. Chart repository is where charts live. We mentioned that a little while ago. Chart repository is any web server that's accessible via HTTPS. Its main thing has to have an index.yaml file. This is anytime we fetch a chart, download a chart, we're actually just looking to the index.yaml file. We're going to then see what location the chart is at and grab it from there. So that's kind of like the source of truth for the repository. So you can use like S3, Google Storage, whatever else you want there. And we also have an official Kubernetes charts repository. So these official charts, and that's actually the equivalent of what I was looking at, of stable charts. These get shipped with Helm by default, so you get access to all of these really high quality charts when you install Helm, or when you download Helm. This lives at github.com/Kubernetes/charts. So we have stable charts and incubator charts. The difference here is that stable charts have to pass like a high quality bar to get accepted. So they're well tested. We make sure that they're working on the latest Kubernetes version. We make sure that it's well documented, and there's just a high barrier to entry. And then incubator charts are charts that the community is working together on or collaborating on. And you're welcome to go into the stable charts and make pull requests if you think one or two things should be more configurable, or something can be better, or you want to fix something. There's over 70 stable charts right now, and about 9 incubator charts, and I think over 70 open pull requests for new or improved charts. So that's growing really fast. And if you don't like looking at a GitHub repo or your terminal to find charts, you can actually look at this pretty UI at kubeapps.com. This is also new. A lot of the work was done by by Bitnami and some folks from Deis, and now Microsoft. And this is basically a nice way to discover charts instead of having to go through repos and your terminal. But what's even cooler about this is that if you have your own chart repository and you want a UI to basically show people in your organization maybe what charts are available to install, then you can actually use Monocular, which is an open source tool to host your own kubeapps.com sort of thing. So yeah, don't build that search and discovery UI from scratch. Another really cool thing that we've been seeing is systems developing around Helm. So people have their own workflows, maybe for CI/CD or for other things, and they just have their own unique use cases internal to their organization in terms of how they want to use Helm. So and Kubernetes and their development workflow. So we're seeing Helm being plugged into CI/CD systems. We're seeing a lot of plugins being developed to extend Helm for particular use cases. We're also seeing just different projects spin up around Helm. It's a really interesting thing to see. So Helm is relatively unopinionated, and it gives you that, the cool part about it is it gives you that abstraction layer to manage your applications, and it gives you that ability to have a package format for your app. And those are the two key components, and really you can use that anywhere in your workflow. Okay, so we're in Australia, and this is not Silicon Valley, it's not London, this is not Germany. It's a lot of Kubernetes stuff is happening in those regions. And I want to mention that just because we're kind of like on the other side of the world, sort of. It's nighttime in where I live right now. So just because we're not in the same time zone doesn't mean that you can't be involved. So I really encourage everyone to get involved with the Kubernetes community. It's a really cool space to be in right now. People are really nice and really smart, and it's just like a fun place to be. So I want to kind of share with you what I've learned about how to get involved in case you're interested in doing that. So the big entry point to get involved with Kubernetes is the special interest groups. So there's a SIG for everything. And those meetings are recorded and on YouTube. And so there's SIG, API machinery, cluster lifecycle, AWS, and I think over 20 more, maybe over 30 more. So the Kubernetes community meeting is a weekly meeting that happens online, and those are recorded as well. And so each SIG does a quarterly update on one of those meetings. So you'll see 2 updates. So if you just watch the Kubernetes community meetings, then you'll get a sense for what the SIGs are doing. And there's also a bunch of documentation on their minutes and all of that online as well. So if you're interested, I would encourage you to pick a SIG that you like. I run SIG apps, so if you want to join, you're welcome to. And there's also a Slack that we have, and you can get an invite to that at slack.k8s.io. And all of the information for all the SIGs is under the community repository under the Kubernetes GitHub org. Helm falls under the SIG apps umbrella. So if you attend SIG apps or watch the recordings, then you'll get weekly updates and demos there on Helm. And we also have 2 Slack channels, the Helm users channel and the Helm dev channel. We have 149 contributors in Helm right now, and we're looking to grow that even more. So if you're interested in doing a pull request, come find me. I will help. And we have some pretty documentation coming soon on helm.sh. So thank you so much for having me. And I have some helpful links if you want to check out the slide after.